This video will cover pre-calc notes 4.2 and trig notes 1.2. The topic for this video is the unit circle, and the unit circle is really important to us in both trig class and pre-calc class. So here's what the unit circle looks like. You have this on your formula sheet. I just want to take a few minutes to explain what you're seeing here. First thing notice is that you're seeing some angles that are written in degrees. And so you'll see here we've got 0 degrees, 30 degrees, 45, 60. You'll also see their equivalents measurement written in radians. So this would be 0 degrees, 30 degrees, pi over 6 radians, 45 degrees, pi over 4, 30 degrees, pi over 3 radians. So as you keep going around the circle, you'll see positive angle measurements in degrees and radians. Then the next thing that you're going to notice is you're going to notice a set of points here. So for example, if we take a look at this coordinate point right here, you have it's an xy comma pair, so x comma y. And more specifically, when we talk about using the unit circle, this really represents a sine and a cosine. So you could actually write each xy value that you see as, instead of x comma y, but rather cosine comma sine. So what I'd like you to do for me, if you would please, is get out your formula sheet and write on your formula sheet right above one of these x comma y pairs, it doesn't matter which one, but write cosine comma sine. That's going to help you remember that x is the cosine value and y is the sine value. The last characteristic about this unit circle is that it has a radius of 1. So, if this is the circle, here's the very center of it. If I go all the way out to the edge, that would be my radius. Notice that this coordinate point is going over 1 and up 0, because that distance, which would be the radius, is 1. The way that these values were calculated, or if we take a look at, let's say, 60 degrees, from here to 60 degrees is 1, and then you have to calculate this value. I went over half, and I went up a distance of square root of 3 over 2. That's all that is. That's how we're getting each of these x comma y values. Okay, as we're using a right triangle, and with a radius of 1, we can then calculate the lengths of both of these different sides. So it's important that you understand that the unit circle will give you both angles in terms of radians and degrees, as well as x comma y values of cosine and sines. So now that we know that we can write an x comma y value as a cosine comma sine, what that will allow us to do is take a look at some formulas that we can write for sine. We can now just write sine if we're on the unit circle. So I should specify on unit circle. I could write sine instead of opposite over hypotenuse, which is what we're used to seeing in terms of a right triangle. I could just write it as the y value. Because really, when we go back to, if we looked at the right triangle that we had from a minute ago, we had something that looked like this. This was 1, this was 1/2, this was the square root of 3 over 2. If we're looking at a right triangle and I want you to find the sine of this angle here, which was, from our example, it was 60 degrees, this is the opposite side. This is the hypotenuse. So basically, this vertical distance was our y value. This was our r. So basically what we're doing is we're doing y over r. But if our r is always going to be 1, it's just going to be y. And so that's why you can just write the value of the sine as whatever the y coordinate is for that angle. Okay. Likewise, the cosine would just be an x. So sine is really just y. Cosine is really just x. Tangent, again, if we go back to the 60 degrees, this vertical distance was our y value. This horizontal distance was our x value. So tangent is, we're used to seeing it as opposite over adjacent. Opposite is as y. Adjacent is x. So we can write the tangent as the y over the x. And now that we know our 3 basic trig functions, sine, cosine, and tangent, to find the reciprocals, we just take and make these all fractions and flip them over. So y over 1 would be 1 over y. X, the reciprocal of x, would just be 1 over x. and the reciprocal of tangent, y over x, would be x over y. So you can now use these formulas in addition to what we've already talked about in previous chapters, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Those are formulas we've done already, but now we can actually use these 6 new formulas to help us find the sine, cosines, tangents, and secants, cotangents, cosecants of an angle that is on the unit circle. Okay, so let's actually apply these with our next example. So if I asked you to give me some information about pi over 3, so if I wanted you to find the sine of pi over 3, the cosine of pi over 3, the tangent of pi over 3, cosecant of pi over 3, secant, and also the cotangent, we just came up with in the last section, or the last portion of the notes, we said that the formula for sine was y, for cosine was x, and for tangent was y over x. So in order for me to be able to use these, I have to know what the x comma y value is for 60 degrees or pi over 3. So if I look at my unit circle here as 60 degrees, I just have a part of the unit circle here, and then this is my x comma y value. Or, remember we write it as a cosine comma sine. So if I want you to tell me what the sine is, you just look at the y value, square root of 3 over 2. I should write this up here for you. We're looking at the coordinate point 1/2 comma square root of 3 over 2. Again, as our x and our y value. So the sine would just be the square root of 3 over 2. The cosine is the x value, which is just 1/2. And the tangent is the x, or excuse me, the y divided by the x. We've got to do a little bit of work for this one. Take the y value divided by the x value, get rid of this by multiplying by its reciprocal. So now the 2's will cancel out, and I'll just be left with the square root of 3 as my answer for that. And then to find the reciprocal values, just take these and flip them upside down. The reciprocal of the sine would be cosecant, so it would be 2 over the square root of 3. But I need to rationalize that. So multiply by the square root of 3, multiply by the square root of 3. You get 2 square roots of 3 over 3 as your answer. Secant is a little bit easier. When you flip this fraction over, you get 2 over 1, which is just 2. And the cotangent, you can either choose to divide it out as x over y, or take this and make a fraction. So it would be, if I put it over 1, then the reciprocal would be 1 over the square root of 3. And then you just have to rationalize it. So if we multiply by the square root of 3 over the square root of 3, we end up with the square root of 3 over the square root of 9, which actually is 3. So we would get that for our answer. So again, just by using the formulas here, y, x, and x over y, we can find the sine, cosine, and tangent, and then take their reciprocal values. And again, the whole way that I did this, the first thing I had to do was find that angle and its x comma y value on the unit circle. Okay, looking at our next example, it says if we have the angle 3 pi over 4, let's find that on our unit circle. Here's 3 pi over 4. Its coordinate point that's associated with it is the negative square root of 2 over 2 and the positive square root of 2 over 2. So that's going to be an x and a y. So if we write our formulas down again, and we plug them in, the sine value, again, was the y value, so square root of 2 over 2. Cosine would be the x value, negative square root of 2 over 2. So those are the pretty easy ones to do. Then to find the tangent, you do the y value over the x value. This time I don't even have to worry about multiplying by the reciprocal. I should be able to do this in my head. This should be a negative 1. And so I can get those values pretty easily. To find the reciprocals, just flip these over. If I flip this fraction over and rationalize, I should end up with 2 square roots of 2 over 2, but the 2 should cancel out and just give me the square root of 2. So when I look at this one, if I was to rationalize this, or first flip it over and then rationalize, the only difference would be for this one, I'd be multiplying by a negative square root of 2 over square root of 2. And so then I'd end up with just a negative square root of 2 as the answer when I rationalize that. And finally, for the cotangent, the reciprocal of negative 1 is negative 1 still. So then I would get negative 1 as my cotangent value. Okay, so let's look at the angle now of pi. So finding pi on my unit circle, this time pi on the unit circle has a coordinate point of negative 1, 0. So this is going to be a little bit tricky because of the fact that we've got a 0 involved, but nonetheless we can still work with it. This is an x comma y. Remember, if I'm asking you to find sine, cosine, and tangent, oops, sorry, it should be y, x, and then y over x. So the sine would simply just be the y value, which is 0. The cosine would be the x value, which is 1. The tangent would be the 0 divided by negative 1. 0 divided by negative 1 is 0. So those are pretty simple to get those answers. Over here, when I think about the reciprocal, so if I make this a fraction, 1 over 0, then the reciprocal would be, 0 over 1. The reciprocal would be 1 over 0. Well, I can't divide by 0. So when I divide by 0, this becomes undefined. I don't get 0 when I do 1 divided by 0. The answer is undefined. Now for the secant, if the cosine is negative 1, the reciprocal of negative 1 is still negative 1. For the cotangent, take the reciprocal of this. If I take the reciprocal of this, it would be negative 1 over 0. Again, I get a divide by 0 arrow, so this would be undefined. So the tricky part about this problem was recognizing that if you have a 0 in the denominator, you can't divide by that. It makes your problem undefined and then not 0. Same thing over here, when you have 0 divided by negative 1, you can do that. You just end up with 0.